All right. Hi, everyone. So welcome to the MedWish Big Data Project. I'll be the project manager and also the lead instructor, if you will, for this project. And as you guys know, we will be analyzing big data. So um, we will be kind of touching on the MedWish data towards the middle to end of this project, which probably should be around late November, early December. Um, and as guys know, we will be using R and we will be using programming. And yeah, we won't be using too much programming. I'll teach you basic operations, such as some display on my screen, which will seem like a lot, but we will decode it slowly. And by the end of this course, hopefully you will know more about R than you started out with. So if your screen doesn't look like mine, that is perfectly okay. I have an older version of R and the R programming language. You guys don't have to match my version. In fact, get the most modern one. I think that's the best way to do things. Um, but yeah, so I usually like to have my environment on the right. You also can have command history, which is here. As you can see, I was running some stuff earlier today. Bottom left, you can have anything from the file, your directory, your plots, which is like anything that you graph in R, packages. So I have a lot of them. They're like I think of packages as extensions to R, like little apps that can change the way R behaves and make it easier or harder to do things. Help is you can actually Google, or Google is the wrong term, but search up the R database as to like things. Like the most recent thing I Googled, or sorry, looked up was power calculation for two proportions. So basically just different sample sizes. And then viewer I've actually never used, but I believe it's just a preview of the code you've generated. I'll show you a case maybe today, which will illustrate why viewer is important. I typically like to have packages on so I can click and unclick these. So you don't have to have any of this open. In fact, you can simply close out of it and disappears. Yeah, these buttons do that. And then also down here is console. You can make it bigger or smaller. I like to have it tiny unless I need something because I like to have the real estate space of a large screen. All right, so to get started, we are going to first create a new R Markdown file. So mine works okay. I will send out a little help document which will help you install R Markdown if you don't have it already, but usually I think R comes shit with these days. So we're making a PDF. I think I'll call the title R Project. We'll call it week 1. I'm planning to make these a weekly thing. I'm pre-recording this, so you guys will see a little bit later than I record it. I'm calling it week 1 just for sake. They might be released weekly or every so often, but yes, definitely within a week they will be released. All right, so we'll create it and this will come up. So just to dig into it, the top is your title. You can change it to whatever you'd like to make it. Author, see as you want to do fit. Output PDF document. So this is all pretty general. So now we're gonna dig into what this is. So I like to think about everything that isn't this. This you can just do that. So that hides it. This can hide something called chunks. Anything that's within these types of notation. So typically it's going to be 3 of these dashes or 3 of these backwards like apostrophe kind of things. All right, so typically in our syntax, you're going to have this. This is what we call a chunk by definition. Chunk is gray shading, and you're going to have these fancy brackets, I like to call them. So typically you're going to have this, which just specifies we're using R. You can actually specify any language, including C++, Java, or Python in here. And this is how you name the chunks. So note this is called setup, and this is called cars. So we can actually go to the bottom and we see this chunk 1 setup. We can actually switch chunks whenever we'd like, and it moves your cursor accordingly. So this is typically called our setup. So setup, you will include all your imports. So akin to Java or any of the programming language, you'd import these packages or extensions. And then this comment include false is where basically it means when you output this document. So when you make it into, we specified a PDF, it won't show up this code. So that's what include equals false does. And this just reiterates it for that function. So we only put stuff that we don't want to appear, so just imports, data manipulation, stuff like that. Yeah, and then this stuff is called white space. So they have this hashtag R markdown is in blue. That means it's like a section header. Think of it as a chapter. And if you go into your outline, which is this little button here, it shows up in your outline. And think of them like chapters. I don't frequently use that, so I usually just delete these so I can save some space and real estate. But just so you're aware, this white space, you can type anything you want. It doesn't have to be perfect syntax at all. In fact, you actually can type perfect syntax. You could literally type in our cars and then and then type this code, but it will never run. However, as soon as you start messing with these apostrophes, these, then they will turn into code. So for instance, if I were to type in the white space, let's say our cars or cars one, you can see it already turned to gray space. So just be careful with using that. If you don't want to show up, I'd use that. This hashtag can also be used to override that. It's like a comment. Okay, so let's dig into it. So I'm gonna quickly write some code for you. So we're gonna use library write Excel, and then we're gonna include a couple other library statements, and I'll explain what each one is as I type it. So write Excel is the ability to import and write Excel files, because obviously you guys aren't gonna generate your own data. I'm going to provide it to you in the form of an Excel file, so it just makes it easier for us to do that. Dplyr is a very, very impressive package. I don't use all its features, but essentially it simplifies commands. I think it streamlines it and makes R faster, in my opinion. Survival is how we generate survival plots. So if you've ever used clinical science, you know there's a survival function, which looks like a step function. It tells you how many people are going to be alive after 2, 5, 1 year, 3 months, whatever. Essentially that. It does a whole lot of things, but for this purpose of this week, we'll be just covering the Kaplan-Meier survival plots. Next week, we might talk about Cox proportional hazards ratios. So GT summary, it just makes cool tables, honestly. Survminer is a fancy way to make Kaplan-Meier survival plots. And in fact, that's what I've used for my own papers and research. Yeah. So these are going to be all model library statements. And I'm going to deviate from what I said earlier. And in fact, I'm actually going to have this section called data import. So yes, anything that's after the R, you can edit. In fact, you can even remove sections, like there's no restriction. And then if it's tedious to add a section by typing those apostrophes, blah, blah, blah. On Macs, at least, I'm familiar with the Command Option I, and it adds chunk for you. I believe on Windows, it's Command Alt I. All right, so this data import, I'm going to say data 1999. I'm not sure what that is. I call them alligator signs. Dash read Excel. And then I'm really bad at this, but I'm going to write the path to that file. So at least on my Mac, it's going to be users, Neil, downloads, Comorb, 1999.xlsx. So what that does is, so this operator is a very special operator. It's the assigning operator. So I'm thinking Java, it's going to be a single equals. Here, it's going to be this. Equals does not work the same to my knowledge, but I've seen people use it. But I like to use this arrow that's traditional. And it's saying I'm going to read this Excel file. So read Excel is what we call an function. So function has its function name, read Excel, followed by these parentheses. These parentheses take arguments. So what if I just forgot the arguments, and I wanted to figure out what goes here? Well, it's as simple as right-clicking, or sorry, I guess maybe mine's not going to work, but you can just type in read Excel on your little help in the lower right, and it'll come up with its syntax. This is a lot more you'll have to know, but I'm just trying to simplify it for my own usage and for you guys, hopefully. This is one I've learned after a while of using R. So read Excel, you just type in its path name, and it'll import it for you. So your path will vary. I believe in Windows, you have like that C:/ I don't know, users, but yeah, save the file wherever, and you can put it as well, in whatever location you'd like. You can even rename the file for all you'd like. So this is just the name of the file I chose. For context, I've generated these data sets from the National Health and Nutrition Survey called NHANES. That's my research focus, at least for now. And I've generated it myself, so please don't give it to other people. And if you ever do use it in publication, please, please, please cite me, because it did take some time to generate. What it did is I using using only this function and this function, I was able to take those surveys from the CDC, combine them, and match the patients based on their demographics. So it's a patient survey. I matched lab values, etc. It's a tedious process. Don't want to bore you guys with it in this one, but that's what I did. So the most important thing is, does my code run? To do that, hit run. You can hit run selected lines, which is if you highlight, you can hit that, or you can just hit run all. I've always done that. No errors. And in fact, over here, sorry, it's really messy, but you can see data 1999 is a TBL-DF 86 length, 6.5, I'm going to say kilobytes or megabytes. And yeah, it's 9,965 observations of 86 variables. So of 86 variables and 9,965 of your sample size or rows. Yeah, so a TBL.df. So table is TBL and df is data frame. Data frame is what you'll be working with most in R. In fact, you can call it from use. You can make a new blank data frame by saying like I don't know, test, and you can just say data dot frame, and it'll just substantiate a blank data frame. But I'm teaching you the practical usage of R. You don't have to be an expert or a programmer. In fact, I am simply just someone who uses packages to manipulate the data to work for me. So this is data import. So what next we're going to do is we're actually going to analyze it. And in this space, I'm going to provide a code book, which will basically show you what's in this file. And if you're curious, usually I hit command and I double tap it. I think you can do control in Windows. And if you do that, it'll open up the file, which is massive by all accounts. And as you can see, there's a whole bunch of numbers and gobbledygook. I know what each one is, but looking at it right now, I don't. I have a code book which organizes the data. And yeah, some of these variables I've created myself, as you can see by a really nice typo for angiotensin enzyme or ACE inhibitors. I just put the T there. So yeah, I'll explain this in a code book, which I will send with my email with this video and other things. So what next we're going to do is we're going to analyze this data. So we're going to use the packages I mentioned earlier. So I'm going to call this section descriptive stats. If it looks different than the thing I provided you, please don't be alarmed. So I'm going to teach you new operators now. So this is from the Dplyr package, so Dplyr, and then from the GT summary package. So I'm going to say, so for this command, essentially I just copy paste, I'm lazy, but you type your data frame, you do this percent, alligator sign, percent. Remember, it cannot be this, it has to be this, the 4 going like to the right. And then you do TBL, I believe summary. This is just calling that table summary function from GT summary. And you say, I'm going to organize this by mort stat. Okay, so let me break this down. So this is going to create a table and it's going to organize into 2 columns, whether the patients are, dead or not dead. That's what mort stat is. It's 0 or 1. It's a binary value. To note, you can do it over a continuous variable, but it will be a very large table as TBL summary tries to generate it for a column for every single value. So what it does is it's descriptive. It gives you the mean, percentage, and standard deviation in some cases for your variables. I have 86 variables, and if I organize them by one of those variables, I'll have a very, very large table, let's put it that way. So typically people use by binary values, or they can use quartiles. Like you have 4 columns of various rows for your observation. So what it does is for each of your variables, it creates a row, and then each of your columns is what your by equals is. I could do by equals and I organize them by quartiles. It'll be 4 columns, etc. All right, it's a little tricky, but what we're going to do is another operator, and we're going to put add-p. This one's pretty standard, and you'll find in most code, even for the documentation for this project, or sorry, not project, but the package. It's just adding the p-value for significance for t-testing and ANOVAs. If you guys don't know what those are, t-test just gives you the significance between means. That's my knowledge of it. And ANOVA just tells you, I believe, the directional value that the means are different. Yeah. And then we're going to do modify caption. So this is what I use, frankly, to make tables in R in my papers and stuff. And for my lab, I do modify caption. So this table generates is pretty bare. So I'm going to add a caption, or in this case, a title. And I'll call this table 1, overall summary of N. Haynes 1999 to 2000 data And then it's double asterisk. Double asterisk is, you don't need it, but I like to do it because it makes the title bold. I like to, it looks more like a publishable figure. And then I'm also going to put bold labels. And what this does, I believe, it just bolds the rows. Yeah. Okay, now let's see if this works. And give it some time. I'm running I like to think a faster computer. So I have like a whatever 8-core laptop. But maybe yours runs slower if you have like a dual core. I'm not too technically knowledgeable in that regard, but give it time. This command can take a bit depending on your operating system and everything you're going on, including how many tabs you have. And you'll see these errors down here. It's because some of these variables, they just aren't significant no matter how much you try to compare them. So as you can see, bolded title, bolded labels, 0, 1. So 0 means not dead, 1 means dead. So from this survey, approximately 1,700 dead, 8,300 alive. And this just gives you the average. So this is the average, and this will, I believe, be your 95% confidence. Not confidence, but within that, 1 standard deviation. So SEQN, you guys can ignore that for your sake. It's how I matched the patients to each of their values in the labs. It took a little bit. So you can see the age is significant. Usually older people die. I mean, that's expected. Otherwise, per month integer is how long they took to die. It appears they took 117 months to die. I'll tell you more about this in the code book. But what's really interesting to me, if I can find it for you guys, is diabetic status. So it looks like 2% of everyone that is or actually this might be better. Or no, diabetes. So actually they're all very significant, as you can tell, but what I'm trying to say is it appears that 20% of everyone in the dead population was diabetic versus only 2% in the alive, which means the diabetics, on average are more likely to die over time. Another interesting one is this, which is similarly just tells you that people with congestive heart failure are more likely to die. Another important one, if I can find it, is, oh yeah, here. So typically, this is BPXR, is systolic blood pressure. My research focuses on cardiology at the clinic and at UH, and this is what I do. So this is what this is telling us is that on average, the people that are alive have a blood pressure of 105 over 61, but people that are dead have it 132 over 68. So an elevated systolic, which is interesting from a researcher's focus. And you guys are more than welcome to explore this. I mean, on your own, read the literature. I mean, if you're interested in it, go for it. But this table is just a very, very, very general overview of that data set. All right, so we generated a table, and now what we're going to do is, well, what if I wanted to restrict this data set? Like, what if I wanted to only look at people who are above the age of 80 or have a blood pressure that, or like a blood pressure or systolic that is greater than normal, that they're having hypertension, if you will. So we're going to do something. Okay, so break it down here. What I'm going to do is I'm going to make a new data frame, assign it to a filtered data 1999, where I'm filtering to some characteristics. So called made a data frame, making its assigning operator, and I'm going to use the term filter. Filter is a command from Dplyr, and as you can see, it even pops up here for me. Like you can put your data, and then yeah, add additional things, which is what you filter by. So we'll say data 1999. That's our data set that we have to begin with, and then we're going to say BPXR, which is your systolic, greater than 1 or equal to 120, or your systolic greater than or equal to 80. Okay. And then what we're going to do is I'm also going to, I guess, just copy paste this. I mean, I don't need to rewrite everything. And I'm just going to change the data 1999 to data filtered. And then I'm going to call this table 2 filtered summary. And then what I love about R is that you are able to put these together, which means you can run this entire chunk together. And what it's going to do, it's going to combine, it's going to run all the code together, and it's going to put them side by side for you. You can click through it and compare it visually, or you can also export it. Exporting is a little complicated, so I don't tell my journal submission reviewers. I just screenshot them and import them into Microsoft Word. Quality is about the same, so no harm, no foul there. All right, so it looks like it's starting to generate. This is the first table we saw already. Obviously, it should be the same. Nothing should change. And then we're going to create this filter data set, and then we're going to do a summary of it, and then we're going to see if it's different. So you can see there's two ways of doing everything is different. So you can go to the right-hand side, you can see data filtered is a table data frame of 940 observations. Data 1999 is of 9965. So you can tell it really, really shrunk the data set down. So it means that filter worked. You can also click on this tab here. You can click that data frame by double clicking and it'll open up here and you could visually go through it and figure out if that change was applied, which probably it was. I'm 100% sure it was. R is very good about those things. And you can see, look at those errors as with some variables that could be dropped. Okay, so, all right, so let's look at it. So people with higher blood pressure, right? So we expect the BPX SAR and BPX star to be, oh, that's interesting. So it looks like it raised the mean. So the people with stats background can tell me what that means, but yeah. Let's see, what else do we have here? So looks good overall. See anything significant emerges. These look significant. So it looks like these variables, which are familial history, not sorry, history of these cardiac diseases such as CHF, angina pectoris, myocardial infarction, stroke, and I forgot what F was, but yeah, interesting. And it also looks like in terms of cardiovascular fitness, they were very, very few that were in the category 3, which means like they're super fit. Majority were not fit compared to, I guess also majority not fit, but you understand what I mean. So yeah, additionally, you can click this magnifying lens, it just blows it up. I don't know if you can see that, but yeah. And then I usually click the X because I like my work to not be so big where I can't see over it. Okay. So that's how you create tables. So this, honestly, you can do anything you'd like. You don't even need to, for example, put by equals. You could just do a univariate is a bad way of putting it, by one column analysis, which puts everyone in perspective. You can do this for any type of data, not just clinical data, just for your information. All right, so we're gonna actually make a new one. And I'm gonna call this data summary, or I guess data summary would be the best term. And this one's be a little more involved and a little more typing. You guys can simply just follow along with your annotated document and feel free to play around, change the names. You can change the filters, see if something changes, do your own little hypothesis testing, if you will. And if you're curious, NHANES is a data set that people have done research on for, I think, generations, ever since the first one. And there's a lot of data on it. If you guys come up with something that's novel, though, you could get published in it, or have an abstract submitted. There's a lot you can do with this. But yeah. All right, so what I'm going to do is I'm going to create a Kaplan-Meier survival plot. So serve per int mort stats 1 data equals data. Okay, just see if that runs. All right, hopefully it ran. I'll explain what it does in a sec as soon as I graph it for you. So I have something to step by. Okay, cool, perfect. So what I'm doing is I'm creating not a data frame now. This is serve fit. So this is called survival fit from a survival package. And serve is a mathematical function that generates a Kaplan-Meier plot. It's called the survival function. That's a statistical thing. So basically the serve fit model, what that does, it takes an X and a Y, and an X in this case is going to be your last follow-up within months, in this case per month int, basically the amount of time that's followed since the last time we followed up with a patient, and then mortality stat, as in, are they dead or not? And then this, I'm not really sure exactly what this is for, but I've been told if you want to add a tertiary variable, such as if you wanted to stratify or separate this curve into two by like whether or not they had like congestive heart failure, you can do that here. Like you can just type in MCQ160E. I don't think that'd work. Oh, I guess that does work. What do you know? So yeah, it looks like people without congestive heart failure lived on average longer and better than people in the blue who had congestive heart failure. But for the purpose of this, I only want the one analysis. And then you put this comma. So within the serve fit function, you need to put comma, specify the data set, and parentheses. And then Autoplot is a package is a function from Dplyr. It just plots whatever function you have. You could do anything, autoplot for anything. It's a really nice one. It makes nice graphs as well. And you can change these captions if you want. I've never really found a need for it in this stage when you're just testing data. But as you can tell, overall survival looks, as I'd expect, a nice smooth curve. All right, so now I'm going to leave it up to you guys to figure out how to make this for the filtered data sets. And I'll release answers in an answer document. So now I'm going to teach you how most researchers use this. So we're going to make this a little more involved. And this, I'll be honest, and I do not know how to do this before, but yeah. So I'm going to create a prettier version of this plot right here using the package called serve minor. I'm not really sure why it's minor, but that's what I've been told to use. So we're going to create the same serve fit object. You'll notice this syntax won't really change. But what I'm actually going to do is I'm going to use MCQ 160B because I think it looks nicer if you do it like that. And then I guess for comparison, we'll do that as well. And then I'm going to actually, let me just run everything. Okay, so we have a baseline. Yep. And then we have created a new thing similar to data survival. I guess I could have even just used data survival as a survival function, but I like to, if I use a object for two different purposes, and they're two very different purposes to illustrate it and to make it easier to modify, I usually separate them, but it is better practice to use this data survival object instead of survival function for this command. So I'll comment it. So this command is called gg plot. And then I'm going to put in survival.function. So usually what I've noticed is in the literature is usually you do like this. You make a new object if you want to test something different. That's what I've been told. So you don't mess up the original object. It'll help you with your code later on if it's more involved. So you call the survival function, and now we're going to put a whole bunch of tags, which I did not know how to use, but it's in the help documentation in the bottom right-hand corner. So we're going to p-value. We want that. We want the risk table there. We want confidence intervals as well as I specified. We want the risk.table.column to be stratified by this variable we put here, MCQ160B, which is heart failure. And then I'm gonna set the Y limits to let's see. In my notes, I set it to that, but I think I'm gonna make it this. What it's saying is I want the y-axis to have for survival from 20% to 100. I'm going to remove this 0 part just because the confidence interval gets too big to be inflexible. Then we're going to put a comma again, and then we're going to put legend dot lab, and we're going to put 2. So I'll talk about exactly what this C is, but it's very useful. So we're going to say no CHF, and then the other one's going to be CHF. And then we're going to put risk.table.height to be 0.3. And then GG theme equals theme black and white plus theme text. Close element. Text. We'll say, equals 20. I guess that would be nice. Okay, moment of truth. Does this work? Nice. It's kind of funky with the fontless text, so I'm actually going to turn it down to 12 and see if that changes. So to note, I hit Command Enter. You can also hit this chunk, or you can hit Run selected lines if you highlight this. I usually just highlight, do Command Enter, or highlight and run selected lines. Those both work the same way. And this error is fine. Just ignore it. It's not really important. So actually I'm going to run it together to illustrate something. A whole thing of R is about evolving. This graph, sure, you can present it to me or a researcher and they'll understand it, but if you present it to like someone who does not really know it or is very sensitive to the aesthetic, this looks awful. And you see these tick marks, which for us, we know it means the patients are censored, but for other people, it would not know. This looks a lot nicer. While the confidence interval here kind of like blanks out, it illustrates something. It tells you the p-value is very, very, very significant. And it illustrates how many people are at risk, meaning how many people are at risk of dying to just everything. So it looks like that overall, the number at risk decreases faster for the people with CHF. There's initially a small population, but it decreases much faster, hence the lower and lower survival probability. While the statistics is very, very complex, and there's a whole course on this at CASE in PQHS department. For us, these two graphs tell the same story, but this one's a little prettier. It just tells us that CHF for people with congestive heart failure are more likely to die over the course of whatever this is. So I think this is going to be 200 months. Yeah, I think it's 200 months in this case, which may not seem like a lot, but if you think about it, that's a lot. But it's just telling of the probability. So it's clearly this is a chronic disease, whatever. Your analysis can go as follows. So my challenge to you guys, additionally, is to create one for the filtered data set, and then create your own filter and make your own fancy KM Kaplan-Meier plot like below being this one. All right, so let me illustrate what this command does. So you put in the survival function, which is literally a mathematical function. I'm sure if I double click, or if you went in here and looked at it, it'd be a mathematical function on the side if you found it. The size just means how big you want this line to be. Confidence interval is your 95% confidence. P-value is down there. Risk table is how many people are at risk. Risk column is you stratify it by the same thing you do here. Y limits tells you I want everything above 20%. Legend Labs is literally just the no CHF. Risk table height just tells you how big it is. I'm not sure what this unit is. I've been told it's pixels per centimeter or something like that, but I always just play around with it until this looks nicer. And I do GG theme black and white just because I found it looks prettier. You can totally remove this command. It's not going to affect things. And let me just be very honest, you can remove things. All the stuff I do is just because I've noticed that's what people do in literature. I did have done for my papers. And this obviously I just showed you the text size. So yeah, and then if you really wanted to see this in great detail, I'm going to really quickly do a knit. So up here is called knit. You hit this button. I'm sure we'll call it untitled. You can save it to something else. And on here you can see this thing called R markdowns running. And I'm quickly, it'll run. Interesting. Okay, I guess maybe we can't knit. I was not aware of that. Or actually, what we do is that. Sorry, I did not expect that error to happen. Well, okay, that's awkward. So I will get back to you on that. But what it does is it creates a PDF of this text, and it just creates these graphs in a nice PDF format. I will hopefully show you guys for next week. Do not expect that error to occur. All right, so that's what I have for this project. Let me know if you have any questions, and I'm happy to help. And if you need me to check over your code or anything, feel free to just email me. I'm pretty available, and I'll be sending this code in a separate email. Thank you guys, and good luck with midterms this week.